Alright, so since none really applied, I'm just going to go through all of them. So number one is pretty straightforward. I'm just going to show you what I did on my homework. That's what my graph looks like, and so I looked up what piecewise continuous means, and there's like two qualifiers for it. The individual functions, so like these guys, have to be continuous on their domain. And there's no discontinuity between their endpoints. So like there's a hole and then not a hole and then a hole and not a hole. So it's all like technically continuous. Number two, also pretty straightforward because it's just the shifting theorem. It's just e to the 7t, so a is equal to 7 and 4 is b and all that stuff. You do cosine and stuff. So then I can go through number 3. So I just realized that my 3a is wrong. I don't have the energy to fix it. I've also already turned in my homework, so there's that. Because if you get rid of that 3s, there still has to be a +1 up there, and then there's just the whole thing. So that's wrong. I don't know how to fix it. Sorry. So then for part B, I factored it here, and I split it up, and then I did the partial fraction decomposition thing and found values for B and A. So for B, I found it to be 1/6, and A, I found it to be 5/6 for the first one, so the s over s plus 5, s minus 1. So that was this bit. And then I did it for the 1 over s plus 5 over s times s minus 1. And then I found b to be 1/6 and a to be -1/6. And then, so that's what this became. So the first one was 5 over 6 times 1 over s plus 5 plus 1/6 times 1 over s plus 1. And the second one was -1/6 times 1 over s plus 5 plus 1 over 6 times 1 over s minus 1. And so then, pulling that all out because they are added together at the top, I just did the inverse Laplace transform. So that becomes, the first bit up here becomes 5/6 times e to the -5t plus 1/6 e to the t. And then the bottom bit is, or the second part is -1/6 times e to the -5t plus 1/6 e to the t. And then I just combine them all together. They get 2/3 e to the 5t plus 2/3 e to the t. And then for C, I kind of didn't really understand. I kind of guessed on this one. So I just said that it was 4 times e to the -3t to the 6th, because that was to the 6th. I guess because if you take the 4 out, it's 1 over s plus 3 to the 6. I mean, there's probably partial fraction decomposition to find out in this. But I don't know how to do that because that's a lot of, like, it's like a over s plus 3 plus bc over bs plus c over s plus 3 squared, and then it's like ds squared plus fs es plus f over s plus 3 to the 3rd, and then there's just like that whole thing. It gets to be extremely long. So this is what I guessed. It might be right. Who knows? All right, and then I'm going to go through number 4 and 5, writing it out because they're a little bit more complicated and involved. So number 4 is y prime minus 3y prime minus 4y equals 0 with y equals 0. Oh, sorry, y of 0 equals 1. And y prime of 0 equals 0. So this uses all of this. It uses these two equations right here. So we're going to focus on this bit because there's a lot. It's very long, but this is what we want. So the first part, the y prime, becomes s squared capital Y of S minus S times Y of 0, which is 1, minus Y prime of 0, which is 0. And then minus 3 times the whole entire bit of Y prime becomes capital Y of S minus F of 0, F of Y of 0, which is 1. And it's just that. And then it is minus 4 capital Y of S equals 0. And then I'm just going to expand this out. So we have S squared Y of S minus 3 Y of S plus 3 minus 4y of s equals 0. And then all in one step, I'm going to move the minus s and the plus 3 over there, and then I'm going to factor out the capital Y of s. Squared minus 3 minus 4. There's an s right there, isn't there? Yes, there is. That's right there. 3s minus 4 equals s minus 3. Now we're going to divide, so we get y of s equals s minus 3 over s squared minus 3s minus 4. And then we can factor this, and then we're going to do partial fraction decomposition, or partial fractions, I don't know what to call it, partial fractions something, to find the values. So we get s minus 3 over, it's going to be s 4 and a 1, that's minus and plus. So then that's going to equal a over s minus 4 plus b over s plus 1. So then that will be s minus 3 equals a times s plus 1 plus b times s minus 4. So when s equals negative 1, we get a to be 0, and then that's going to be negative 4. A is 0. So then b is multiplying by negative 5. So then b is equal to 4/5. When s equals 4, we're going to get 1 equals 5a. So then we get a to be equal to 1/5. Then we plug these back into this equation, and then we have 1/5 times 1 over s minus 4 plus 4/5 times 1 over s plus 1. So then this is just e to the at. So we get the inverse Laplace transform of y of s is equal to 1/5 times e to the 4t plus 4/5 e to the negative t. And that's the answer. Alright, then number 5 is x prime plus x equals sine of t plus cosine of t, with x of 0 equaling 0 and x prime of 0 equals 0. So first thing, do the inverse Laplace transform of all of them. So that becomes, so the inverse Laplace transform of this will be, for x prime, is s squared f of s minus s times f of 0, which is 0, minus 0, plus the inverse Laplace, the Laplace transform of x, which is just f of s, That equals the Laplace transforms of the other side. So sine of t becomes 1 over s squared plus 1. Cosine becomes s over s squared plus 1. So then we get, I'm going to do this real quick. So we're going to factor out that. These are just 0, so these are gone. So we're going to get f of s times s squared plus 1 equals, I'm going to put these together, 1 plus s over s squared plus 1. And then we're going to divide, equals 1 plus s over s squared plus 1, quantity squared. Alright, so I assume this is where a lot of you got stumped, but this question right here, this was on the quiz. I believe it was number 2, maybe 3. Alright, so then to solve this, we need 2 formulas that are in the book. They aren't on our sheet that we got a few weeks ago, a week or two ago. So I wrote them down right here. That's the Laplace transform of t sine of bt is equal to 2bs over s squared plus b squared quantity squared. So that looks like this, where b equals 1, and we have an s over there and stuff. Because we're going to split this in a second. And then the inverse Laplace transform of 2b squared over s squared plus b squared quantity squared is equal to 1 over b sine of bt minus t cosine of bt. So I'm going to split this up, and then we're going to get them to look like these guys. So it's going to be f of s equals 1 over s squared plus 1 squared plus s over s squared plus 1 squared. So these both have a 2 in it. So if we multiply the entire thing by 1/2, we get 2s and a 2 up there. And so that gets us the 2 that is in both. So now, this one right here looks like this one. So we're gonna do that one first, and then I'll go to the other one because that one looks like the other one. So the inverse of this will then become, we have 1 over 2 over the entire thing. Just do that for all of it. And then we have b squared, b is 1, so that's just going to be 1. Sine of 1t minus t cosine of 1t. So that's that bit. Then we're going to add this bit right here. Looks like this now, where b equals 1 and s is s. So then it becomes t sine of bt. And so that's just that, and that's the answer. The inverse Laplace transform of f of s is equal to 1/2 times sine of t minus t cosine of t plus t sine, oh I forgot to get rid of the b, sorry, sine of t. And that's the answer.